Okay, sorry for the slight delay. I think it's 10:31, so I think we'll begin. Welcome to this presentation. I'll be talking about clash detection for designers today, and just some best practices and methodology for managing clashes at the design phase. My name is Yigit Karanfil. I'm the Design Technology Manager at HOK for Canada. I've been working as a multidisciplinary BIM expert for several years, and I am an active member of CANBIM Designers Steering Committee. So this presentation is going to be about the process, and it's not a step-by-step instruction. I have been using Navisworks and like Revit for modeling basically, but this process could be implemented to any other software basically, as long as you are, as long as you use a software for authoring that contains information. You can use this with different authoring or reviewing software. So I'm hoping this will be a bit more universal rather than just this is how to use Navisworks. And so the suggested workflows here, just to iterate again, this is for design coordination. When you go to construction phase and you're trying to coordinate your models there, that's a whole different game. So design only. So I guess the first question is, well, I mean, you're in this room, you came to this event, so I'm assuming you're sold on the idea, but I'll just go over why do we do this? Why do we do clash detection? Why is it even necessary? We weren't doing this 20 years ago, you know, that all those comments you're going to probably hear from some more experienced PMs maybe. So what we're trying to do at the end of the day here is deliver a design that is constructible. And we are responsible as designers to deliver something that is that works, that is constructible. And clash detection is a great tool to coordinate this design when you use it right. So there are a lot of kind of pitfalls that you can run into if you are not following a very organized process. But when implemented right, it will help you a lot in means of coordinating your models and your design. And the whole idea is to proactively prevent the issues that can happen on the site. Because as you may know, the design is usually somewhere around 5 to 20% of the total project cost. I mean, this is the ballpark number taken from the RAIC guide. But most of the costs incur in the construction process itself, and design is a smaller part of that. But still, if you don't design right in the first place, it can also cost the design company a lot of money to kind of fix those issues later. Excuse me. So these basically are the things you will need roughly in a design coordination process. And these obviously cost money. So BIM managers or coordinators that are going to be working on your project, you have to pay their salaries, you know, not every company can afford one maybe. Actually, it's mostly larger companies that have people assigned specifically to these roles. And I mean, my unbiased opinion is they should be paid very well. So you know, there's always that.
Talk to my boss about that.
Sure. And the design coordination itself also costs money, which is something we should be doing anyway. And when I was talking to actually one of the really experienced designers in a previous company, he was telling me we would, like before this whole clash detection and the technology came in, we would spare about 10% of our fee for coordination. I wonder these days, where did that 10% go? I would gladly take 10%, and we would be able to easily do all these with that fee. And finding the clashes and fixing them also will have a cost for the designer, which basically is time you spend on the project. But these are the things that happen when you don't do clashes. They also cost money. things like construction administration, which you are contracted to do in many projects. Responding to a bazillion RFIs, that's going to take a lot of the time from of your project managers and designers, architects, engineers. Bad or incomplete design, that basically leads to all those RFIs usually, and to design changes. Now the design change itself will cost you because you're going to have people working on that design change, and also there will be workers just sitting at site costing you thousands of dollars, basically just, they're getting paid to do nothing because they are waiting for the new design. Also schedule delays obviously will cost you, and the costliest of them all is an unhappy client because their project is not delivered on time, or there are things that are not working out with it. So in conclusion, I think these costs are higher than these. So it is worth going through this process. Now the process itself, basically how a lot of people think this works, unfortunately in the industry, thanks to marketing, is you just export your models to clash detection software, and there's just a giant button that says fix clashes, and all the clashes are found and fixed automatically, and there's nothing clashing anymore. Also the sun shines, a unicorn walks by, birds are chirping, all that stuff. So that's basically what your boss was told at some point. And if you're not familiar with sarcasm, it's not true. So we're going to go into some of those kind of myths, like how people, when I say people outside of this room probably, and how it is perceived sometimes these processes work, and what is the truth about them. So myth one, finding clashes is an automated process. Now, this is partially true because the software can look at your model, and all it tells you is there an object running through another object? And the answer is yes. It's a construction model. It has a lot of, it's a very complex model with a lot of items in it. So this is definitely going to happen, like a lot. And what you need to do is actually sort this data before you run through the clash detection, so that, and that process itself is not automated. And you're the person, as the BIM coordinator or the manager, or even the project manager, determining what data is useful to you and what you should be looking for in the model. And you basically need to take the time to outline these processes and to coordinate them. And you can use some templates to speed things up, but each project is different, so you will very likely need to kind of modify your processes a bit for every project you do. And exporting models can be automated, and once you set everything up, it's a relatively easy thing to run these over and over again. But it's not as automatic as people usually think it is. And this is where basically your the information part in BIM really pays off, because you're completely relying on the information on the model to sort all this data. Another myth, all the clashes in a model must be resolved. So as I mentioned, these are complex models. Like, we're building much more complex buildings than we did even like 50 or 100 years ago now. So there will be a lot of items that are clashing, but that doesn't mean that all of them are relevant. So we really need to find the ones that will affect the constructability, or they will have an impact on the design itself. So we have to kind of sort it out and find what is relevant to what we're trying to achieve with this whole process. Another myth is font clashes are fixed automatically. That is definitely not true. The real architects, engineers, designers have to look at these clashes and find a way to resolve them, just like any other problem in a project. Because basically, if we had a system that would solve these automatically, I'm not sure if anyone would really want to use that. Imagine somebody has run a sprinkler pipe through a railing, like a stair railing. And don't tell me it doesn't happen. It happens all the time. And your software decided, oh, I'm just going to move the railing down. Now it's not code compliant. So that wouldn't really work great. So it would really require a lot of advanced AI technology that, to my knowledge, doesn't exist on the market today. So for now, we're going to have to handle these all like one at a time and fix them with real people. Another myth is, now I've been talking about all these there's going to be a lot of clashes, not all of them are going to be relevant. So clash detection produces a massive list of conflicts where majority of clashes require no action. So, I have 5,000 clashes, but there's nothing to do about these. And that is actually true if you are not following a process that helps you sorting them out, which is what we're going to talk about today, basically. You really need to tell the software what you're looking for, because the software, as I said, is actually once someone from somewhere in a company I work for in the IT department told me, computers are dumb. They just are good at doing tasks repeatedly, but you need to tell them what to do, everything like step by step, basically. And I think that's very true. And we have to be just smart enough to tell the computer, we need to be very specific so that we get the results that we're looking for. So with all these, basically, so how do we find those clashes? What's the process for them? The first step in this whole process is to find our clashes. And what we're looking for is clashes that are actionable, that are organized, that are data-rich and relevant. And again, we're really relying on the information in our models. If you end up doing flat CAD exports, for instance, that's not going to give you very valuable data. So you can export your data in several different ways. The more information you have, the better results you will be able to get from this whole process. The data in your models will really allow you to sort through the items and find exactly what you're looking for. And you should always use formats that carry data, like NWCs, IFCs, or whatever format that basically can contain more properties than just geometry in your model. And you really want to narrow down the number of clashes doing this. So this is a mistake I see people do all the time. Basically just saying, I have this model, give me a clash report of this model with itself, basically. I have everything here, so I'm just going to hit the button and find the clashes. This is not going to be very useful because it's going to generate this. So this is 6,000 clashes in a 30,000 square foot office project. And that is a ridiculous number for a project of this size. And the reason this is happening is it's reporting you everything. So, and when I say actionable clashes, so here are some examples of non-actionable clashes. So here what you see, for instance, there's a receptacle. You see half the picture, unfortunately, but there's a receptacle on this wall, and it's reporting it as a clash. And I need to do absolutely nothing about that. That receptacle is supposed to be there. So that is completely useless for me. So if I'm looking through 6,000 clashes and half of them are like this, I'm going to get tired of this process very quickly. Other examples of these non-actionable clashes are things like pipes or conduits penetrating a partition. I keep seeing different maybe Dynamo scripts and such to automate creating openings on partition walls and such. I'm yet to understand the point. At least from a design perspective, these are really not very useful for us. It's a partition wall. Just make a hole and make the pipe go through. That's all. a diffuser on a ceiling. The diffuser is supposed to be on the ceiling itself. And something like a flex pipe clashing with another pipe. Just somebody's just gonna move it in the site and bring the solid pipe through no problem. And here are some examples of what we're looking for, basically. So the one in the picture here is a duct running through a beam. Sorry, this is a cable tray running through a duct. So that you definitely want to resolve. These are two solid items that are not going to work on site, basically. Other examples could be like a duct running through a window, for instance, or a pipe running through a beam, a diffuser clashing with a smoke detector. They just can't be in the same place. So these are the kind of mistakes you're looking for in the model. So the first step when we're beginning this, so we went through some examples, and the way to find these examples is to first determine what elements you're looking for. There are some elements in your model that are not relevant to constructability at all, basically. So you can pretty much ignore them for the most part. Your project might have specific needs, and you would just gear up your BIM execution plan and the whole process towards that. But generally, there are items you can ignore, such as furniture, for instance. So services below certain dimensions can be filtered out. 2 inches or 50 millimeters is generally accepted in the industry as a reasonable threshold. It can be lower or higher depending on your project. It's just something you need to sort out with your clients and your subs, maybe sub-consultants. And if clashing items are barely in contact, it's likely still constructible. Remember, we're not building a LOD 400 manufacturing model here, so you got to set those tolerances both in your software and set them in your BIM execution plan. And it's very important to write these down so everybody knows what they're getting into. So when you send, let's say, your mechanical engineer a clash report, they're not going to question what this is or why they need to resolve these. And the next thing you want to do with those selected items that you think are relevant is to make a priority list. At least this is my approach. So not each element has the same weight. The idea is to put the items that are harder to move on top of your priority list and say that these are the top priority. If something is clashing with this, I can move the other item. The harder to move items are typically structural is a good example, because usually if you're running through any of your items is running through a beam, for instance, and you ask the structural engineer to move the beam, most of the time the response will be to just take a hike, because there's not much there can go. There are cases where structural is modified, but it's relatively rare. And one important thing to keep in mind here is it might change depending on your project type. So what is a higher priority and what's a lower priority? This is not there's no blanket statement saying ducts are always more important, or I don't know, the conduits are maybe lower, or there's no real how would I say set standard here. You will have to judge by the type of your project, and you know your project best, so you got to talk to your consultants to figure this out. So when you make that list, it will look something like this. As I said, so this is I think good example in general, but it's not necessarily going to work for every project. These can move around depending on your project type. So in this project, for instance, they decided architectural elements have about the same priority. So I just kind of grouped the doors, windows, curtain walls. Maybe those are the architectural items I'm trying to coordinate, so I kind of put them to priority 2, and structural is on 1. And then you also see that I've sorted different mechanical systems in different lines, because just routing slope piping is much harder actually than routing pressurized piping, because you can do you can dip down and go back up with the pressurized piping. Slope piping has to be at a constant slope all the time, so they are much harder to route. Or things like fire piping, for instance, they need to be at specific locations so they reach the sprinklers. So where they go to is a bit more important, maybe. So those are the kind of things you need to consider when building this list. And also having your, if you're not like an integrated practice, it's a good idea to, put this in your BIM execution plan and just check with your sub-consultants so everybody's on board and you're not going to get objections like 3 months down the road. And one thing you will realize here is a lot of items are M&E related, and that is normal because that usually is what requires the most coordination. So as I mentioned, the lineup on the list could be different. Some examples of this is transportation projects, for instance. They have a lot of conduits, they go in bundles. So you might want to put them at a higher priority because they will be much harder to move around in those type of projects. If you have a data center, something that's not even in this list, like cables, will be a big mess basically. So you probably want to maybe model your cables and just put them at a higher priority. Okay, so and this priority list will basically also determine in which order we're resolving them. I found in the past that if you issue all your reports at the same time, when people are moving things to avoid items, they're just creating other clashes because 5 people are changing the design at the same time. So doing it in order is usually a good idea. And for the priority list, a good resource would be CanBIM's BIM protocol, the 3rd version. This will be available soon. We've been working with Designers Committee on this. I was hoping to have this launched by now, but didn't happen. It should be out pretty soon. And I guess I have to disclose that I am self-referencing because I am on the Designers Committee and I've been working on these documents. But there's like a 1 or 2 page write-up about this whole process over there. So one tip when you're looking at those items, so when you're trying to find the items in the priority list, it's a good idea to create search sets or use some sort of parametric finding system in your clash detection software. Because if you're using, I've seen in the past people use things such as work sets or like maybe less reliable things like layers work sets. So those are not going to give you very granular information and they're very prone to mistakes. Basically you're again really relying on the information on the authoring software. So it's very important that the systems and the items are modeled right, so they would actually be able to, so we would actually be able to find them when we are running our clash detection. One tip here, this is kind of Navisworks specific, but what I found is like if you're trying to find ducts, for instance, I don't want to see my ducts, duct fittings, duct accessories all in like different categories. Like I want to treat them as one. So if you use a contains syntax, that kind of saves you from having to enter like 5 lines of items, and it's going to find everything duct related, for instance. So that's just a small tip over there. Okay, so now we have our items that we want to run clashes on, and we have a priority list that will help us determine how we run this entire thing. So it's time to kind of create a clash detection test. So what I would do is, in this example, I'm using ducts as an example. So ducts are number 4 on the priority list. So that means anything that is above ducts is more important than the ducts. So I would run a test. So unfortunately, again, you don't see this side of the screen, but so I would run the test against ducts versus slope piping, the architectural items, and structural elements. And that is basically giving me an entire list of everything I need to fix with ducts, as far as clash detection is concerned. Basically, if there is a clash, like when the clashes are found, the natural thing to do will be to move the ducts, because everything above it has higher priority than the ducts. And we're going to talk about what happens if that's not feasible a bit later. And basically, you would create all your tests using the system. So if I'm looking for, so I would basically just start from the top. For structural elements, I probably don't have anything to run for. And for the architectural items, I would just clash it with what's on top of it. And I would move down and do the same thing. And as you repeat this process, that is the list of the clash tests that you need to run on that project. And once you find those clashes, I think it's very important to group those. I think that's a step sometimes missed, because in this instance, for instance, if I move this cable tray, it's going to resolve 3 clashes. It's clashing with a pipe, with a duct fitting, and the duct. So the problem is, when the electrical engineer moves this cable tray, my problem will be solved. So I don't need to really issue this as 3 separate clashes. And grouping these properly will reduce the number of clashes that need to be solved by designers quite a bit. And that really helps with morale. And I think it's a bit underrated how heartbreaking this can be, because you don't want to see someone's face when you hand them, like, okay, you need to resolve 2,000 clashes now, versus 500-600. It's just a much better number. It's still not great, but it's still not great, but it depends on project size. Okay, so once we went through our list, and we determined which items are getting clashed, and we determined all our clash tests that we want to do. And now we're basically getting into the coordination process. And one thing I see in BIM execution plans sometimes is we're going to issue the clash reports 2 weeks before submission, and we're going to resolve them all. No, you won't. There is no way in the last 2 weeks people are going to work on clashes and actually resolve them. It's just everybody is in panic mode already, and they're doing all these last minute changes. It's unlikely to happen. So it's better to have this as an ongoing process than limiting it to this much time before the submission. And I think in my experience, so this depends on the project type, because I've seen projects where you have one project that has like 7 different submissions, and they're all in like different phases. So it can get complicated. But in general, I think design development is a good phase to start this process, because schematic design, you're still moving items around like way too fast, and it's just the design is. A clash you find today is not even going to be there tomorrow, probably. They maybe completely change the design. So it's not really very useful to do that in that phase. But design development, you can kind of start doing it and maybe increase the frequency of the clash tests as basically the project ramps up, and you can do like maybe weekly basis when you're in the CD phase. And if you really need to, though, in earlier phases, you can just kind of set really high tolerances. So you're looking at those like really large items, like if your mains and such. So it might be a good idea to look at those. But anything beyond that, you're better off just avoiding, because again, it's not going to be there very likely when you look at it the other day or next week. And now basically we've found our clashes, right? And we want people to resolve them. So we're going to look into how that process works. So what happens first here, so I'm giving an example of a clash between a conduit and a duct, and the conduit has lower priority than duct. I'm just basing this off the chart that I've shown before. So conduit has lower priority. So what happens is your BIM coordinator sends the report to relevant model element author, basically the guy who's modeling this element, and asks to kind of fix the clash. In this case, that is the electrical engineer. So electrical engineer reviews this, and there are two courses that they can take. If they can move the conduit, which is the preferred action, they would just move the conduit, clash is resolved, we're done. If not, let's say they have a case where it's not feasible to move that conduit, then they would go back to the mechanical engineer, start a discussion with them, and then get to the resolution, whatever that's going to be. But basically, in most cases, they can just kind of take action and get this resolved. And we don't spend like 5 hours in coordination meetings for every single one of them. And also, I think one point to make here is sending information in smaller chunks, as I mentioned, like an ongoing process is usually better, because if they see like thousands of these at a point, it's going to be like pretty hard to both assign staff and kind of handle them at the same time. And sorry, one more thing I want to note is like electrical engineer should likely get only the clashes that are relevant to their discipline. So let's say if mechanical and architecture are having a problem, it's none of their business. Like they don't need to be involved unless the change they do, they will make is going to have an impact on the electrical engineer as well. Otherwise, like they can be completely uninvolved and they don't need to see any of that. So to distribute the clashes, basically there are a couple different methods. So option one is to have just a flat document, basically. So this is what Navisworks gives. You can have this in PDF, spreadsheet, HTML. It's all the same thing, basically. It's just a flat table that tells you line by line, this is the clash, this is a picture of it, and some other information such as what is the category of the item. I think it's useful to have there. And I think the most useful here is the element ID, because the element ID is definitely the best way to find an item in Revit especially. There is just no mistake when you type that in, it will find that item. So without that information, I know we can export things like grid line, intersection, level, and such, but it's not as useful as element ID because it's kind of just foolproof. Option two is to use the clash detection software directly. So everybody has this open on their computers, and they can go through the clashes themselves. They can use maybe switchback tools and such. Of course, the problem with this, I think, is the entire team needs to know how to use it, whether it be like Solibri or Navisworks, whatever you're using. You need to teach that to the entire team, and that can be a challenge. And you're also sending relatively large files because, these are usually smaller than the design models themselves, but they're still much larger than just a spreadsheet or other types of data you can send. And the third option is to use a cloud-based collaboration software, which is my preferred method personally, because this allows a couple of things to happen. It can track clashes in real time, first of all. So when a clash is issued, everybody that is relevant to that can be notified, and it gives you more information. It can actually record a lot of these software can record the location of where the clash is happening, and it also provides you a platform for communication. So you can kind of start commenting on an issue, rather than walking to someone else's desk or just emailing them. You can start the conversation right there and then close the issue basically pretty quickly. And that really helps, especially if there's a distance between the teams. Let's say we're working in Toronto and we have a consultant that's in Vancouver, or I don't know, maybe in China. Honestly, like it depends on it's a global world. We get work from different countries, or maybe we collaborate. So it provides the platform for making all these possible. And they are generally much easier than just getting a handle of the either clash detection software or the authoring software. Those are, the learning curve is going to be much lower, and you can even get your project managers to actually keep an eye on this, and they can frequently look at the project and see what status it is in, and they'll be aware of all the issues. So it's a good way to engage them as well. So option 3.5 is using BCF. BCF is a BIM collaboration format. It is a format that's been adopted by Building Smart, which I actually didn't know. I learned when I was researching for this. So I thought they developed it like IFC, but they actually adopted it. So this is basically a open source collaboration format. So it will basically create a file where it will record model information. It will record coordinates of your coordination items, and also a PNG image that goes with it. So it's basically kind of like the smart way of conveying the information. And the nice thing about this is if you're using any of the software here, a lot of them actually also work with BCF. So if you had a case, maybe people insist on using different software, or it works even with authoring softwares like Revit actually even has a kind of BCF input. So if you have a hard time getting people on board with the software that you use, you could use BCF to exchange data basically. And unlike, I think there are issues with IFC where, if you're trying to use it on a design model, it causes some serious issues. But with this, it's just pretty simple. It's just information, coordinates, and an image. So I think it works pretty good most of the time. Okay, so conclusion. Clash detection is not a simple process. It requires a lot of expertise. It really has to be suited for your project. You need to, tailor each and every BIM execution plan and your process for each project. And many companies still don't do it. It's just kind of hard to, this is kind of the general problem with BIM, I think, where this will very likely save you a lot of time in your construction administration, or just going to prevent a lot of the issues that will come down the road. But that upfront investment, like with many things in BIM, is a bit of a tough sell. Also, quantifying it is hard, I think, because you're basically preventing issues. So how do you show value for things that never happened, basically? So I think that's the biggest problem. But it can really be easier with good communication and planning, and it will be it can be an essential part of reducing your coordination errors, and I think it's really worth it at the end of the day.